Saxon's Trig, lesson 49, is about the logarithmic function and development of the rules for logarithms. And it starts on page 338. Very rarely do I feel like Saxon taught something in a way that wasn't really necessary. Unfortunately, this is not one of those lessons. I feel like it's kind of irrelevant, but I'm going to give you the basics just in case it is extremely helpful for some of you. So when we are dealing with the logarithmic function, if I have it in an exponent format, I know that when I have a base and it has an exponent, the graph that I'm getting is some kind of a curve. And when I have it in its log format, I have to remember that this rearranges to an exponent format, which means it also graphs a curve. So I've already memorized that exponents graph curves, and now I'm learning that logs that turn into this also graph the curves. The only major difference is that here, the thing that I would be, my x value would be the L, and then the answer would be the y value would be the n. Here, if you're doing it on the calculator without rearranging it to this format, your n is your x value and your L is your y value. They have flip-flopped. So if you look at the graph that they give you, you'll notice that for this one, the x values were things like 1, 2, and 3, and then they were getting a larger number and getting their curve. On this one, they're getting the same curve, but these are the bigger answers that I was getting here. They're on my x line, and my 1, 2, and 3 that were here before, they're coming over to here. And so the curve goes to this. Again, what is the major significance? I'm not really sure. Now that they've talked about that, they move into developing the rules for logarithms. We just learned these rules that said when n and m are multiplying, that we basically have the log base b of m is adding with the log base b of n. Oh, I should have said my log base b, m, n. Okay, that they're separated. When you're multiplying, you're really adding. And I sort of explained it when we did it before, but they want to stop and kind of explain a little bit more here. So if I give the statement log base 10 of 10 to the second, the log base 10 and the 10 kill each other off, and the log solution there is 2. Same kind of thing happens if I give it an exponent of 3. They kill each other off, and you just keep the 3. So what happens when you take a 10 squared times a 10 cubed? Well, when we multiply bases, we add exponents. So this is 2 plus 3. And if you turn that into the statement with log base 10 of 10 to the 2 plus 3, you're killing these off and you're keeping that 2 plus 3. So it started as a multiply, it ends with addition. That's the proof there that that works. Okay, so then the same thing happens if I have 10 to the third and I square it. I have one base, 2 exponents. What's the rule with that? You multiply. So you're getting 3 times 2. And if you turn that into the base, so if you have it multiplying, then it is really becoming in front to log base 10 cubed. They're killing off and you're doing 2 times 3. I hope that this is kind of making sense. And then the same sort of thing if you are dividing and you've got 10, does it matter which order? I just wanted to kind of match theirs. Oh, there it is. 10 cubed over 10 squared. That's how they did it there with the division. So when you are solving that, it goes to 10 to the 3 minus 2 because you're moving it up, you're changing its sign, so the division changes over to minus. And then if you put that into log base 10 of 10, you've got the 3 minus 2, and so you know that when it was originally dividing, it's now really subtracting. Okay, so we've gone through the 3 basic rules. Now they say Now that you see that it has applications into the exponent format, everywhere we had a 10 to the third, we're going to call it an n. And everywhere we had a 10 squared, we're going to call it an n. And now that means I can substitute things that now say basically log base b of mn means log base b of m plus log base b of n. Log base b of m divided by n means log base b of m minus log base b of n. And the final one, when I have log base b, and I've got n here multiplying with m, that this really means log base b of m to the nth power. I think that's the way they wrote that last one. I feel very confident about the others. Was looking to see, this should match what we did on the other lesson with all of those rules.